Hello everyone, in this video we're going to learn how to prove the alternating series test theorem. Let the series b sub n greater than or equal to 0 for all n. The alternating series a sub n where a sub n equals -1 to the n times b sub n, or a sub n equals -1 to the n plus 1 times b sub n. Converge if limit of b sub n when n approaches infinity equals 0. The sequence b sub n is a decreasing sequence. What does it mean? It means b sub n always greater than or equal to b sub n plus 1 for all n greater than k, where k is an integer. Alright, so this one is given, right? And we need to prove that this guy right here converges, right? So we're gonna start off with this one right here, right? So we have b sub n greater than or equal to b sub n plus 1. It tells us that b sub n minus b sub n plus 1 greater than or equal to 0, right? So now I'm going to let s sub 2 equals b sub 1 minus b sub 2, right? N equals 1, you have b sub 1 minus b sub 2, right? And this guy actually greater than or equal to 0, right? Now s sub 4 equals b sub 1 minus b sub 2 plus b sub 3 minus b sub 4, right? And I can replace this guy right here with this guy, right? So it's going to be s sub 2 plus b sub 3 minus b sub 4, right? And this guy actually greater than or equal to s sub 2, right? Now next one, s sub 6 equals s sub 4 plus b sub 5 minus b sub 6, right? And this guy actually greater than or equal to s sub 4, right? Now I'm going to generalize this one, so I have s sub 2 and it's going to be equal to s sub 2 n minus 2 plus b sub 2 n minus 1 minus b sub 2 n, right? This guy actually greater than or equal to s sub 2 n minus 2, right? So we just prove that s sub 2 n greater than or equal to s sub 2 n minus 2. This guy tells us that s sub 2 n is an increasing sequence. Now I'm gonna rewrite s sub 2 n equals, right? I'm gonna combine all of these guys right here, right? So it's gonna be b sub 1 minus b sub 2 plus b sub 3 minus b sub 4 plus b sub 5 minus etc. minus b sub 2 n minus 2 plus b sub 2 n minus 1 minus b sub 2 n, right? Now this guy turns out to be b sub 1. Now I'm going to group this guy and this guy, this guy and this guy, right? This guy and this guy. So it turns out to be minus b sub 2 minus b sub 3, right? Minus b sub 4 minus b sub 5, etc. Minus b sub 2 n minus 2 subtract b sub 2 n minus 1, right? And minus b sub 2 n, right? You know that this guy always greater than or equal to 0, right? Look, right? This guy and this guy right here, right? So then s sub 2 and big one subtract a positive number. It tells us that s sub 2 n is always less than or equal to b sub 1, right? For all n. And we're gonna combine this guy together. It tells us that S sub 2n must converge, right? In other words, limit of S sub 2n when n approaches infinity equals L, right? Now, if you do exactly the same thing for the odd partial sums, S sub 2n plus 1, right? You're going to end up with limit of S sub 2n plus 1 when n approaches infinity equals limit of S sub 2n plus b sub 2n plus 1 when n approaches infinity equals limit of S sub 2n when n approaches infinity plus limit of b sub 2n plus 1 when n approaches infinity, right? Now, this guy right here equals 0, right? If you look at this one right here, right? So then you're going to end up with limit of S sub 2n when n approaches infinity equals L is to be right here, right? So we just prove that S sub 2n and S sub 2n plus 1 converge. And limit of S sub 2n when n approaches infinity equals limit of S sub 2n plus 1 when n approaches infinity equals L, right? These two guys tells us that the series A sub n is convergent. By the definition of infinite series you learn in topic 10.1, right? And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher.